Blue Ocean Event 2024. On February 1, 2024, the daily sea surface temperature reached 21.12 degrees Celsius, the highest temperature on record and higher than the August 2023 peak of 21.09 degrees Celsius. Could the temperature increase even more over the next few months? As the image also shows, the highest annual temperatures were typically reached in March for each of the previous years on record, except for 2023 when the current El Niño started to emerge. According to NOAA, the majority of models indicate that this El Niño will persist through March-May 2024. The second image shows a drop in sea ice extent at the end of January 2024, blue, a time of year when Arctic sea ice is still expected to increase in extent and to keep increasing in extent for some time to come, gray. In this case, strong wind may have caused a huge amount of ocean heat that is present in the North Atlantic to move abruptly toward the Arctic Ocean. Changes to the jet stream and ocean heat accumulating in the North Atlantic Ocean are feedbacks of the overall temperature rise. A further rise in ocean heat in combination with the steep rise in insolation hitting the Arctic in April and May could suffice to cause a blue ocean event, BOE, to occur in 2024. A BOE occurs when virtually all sea ice disappears and less than 1 million square kilometers of sea ice remains. As the sea ice disappears, the surface color changes from white, sea ice, to blue, ocean, resulting in far less sunlight getting absorbed by the Arctic Ocean, instead of getting reflected back into space as it previously did. Albedo change constitutes a self-reinforcing feedback loop, i.e. the more sea ice disappears, the more sunlight gets absorbed by the Arctic Ocean, further accelerating sea ice melting. Next to the albedo loss, there is loss of the latent heat buffer constituted by the sea ice. Latent heat is energy associated with a phase change, such as the energy consumed when solid ice turns into water, i.e. melts. During a phase change, the temperature remains constant. Sea ice acts as a buffer that absorbs heat, while keeping the temperature at about 0 degrees Celsius. As long as there is sea ice in the water, this sea ice will keep absorbing heat, so the temperature doesn't rise at the sea surface. The amount of energy absorbed by melting ice is as much as it takes to heat up an equivalent mass of water from 0 to 80 degrees Celsius.